guys, have you ever been to a beach? I'm sure you have. Well, if you've been to a beach, you may have played with the sand and even taken bath in the sea water. The last time I was bathing in the sea water, I swallowed some of it. And guess what? It tasted salty. We all know sea water is a mixture of water and different kinds of salts. But have you ever wondered why the salt is never visible to us? Let's study more about mixtures before we try to answer this question. Let's take a glass of water and add some salt to it. On mixing thoroughly, we see that the salt dissolves in the water. Now let's take another glass of water and this time add some sand to it. Do you see the difference between the two mixtures? In the salt and water mixture, salt particles cannot be seen separately. Such mixtures are called homogeneous mixtures. In the water and sand mixture, sand particles are clearly visible. Such mixtures are called heterogeneous mixtures. Which category do you think milk should be put in? Well, it looks like a homogeneous mixture as milk particles are not seen separately, but it is a heterogeneous mixture. Let's see why. In homogeneous mixtures, like that of salt and water, the size of solute particles is less than a nanometer, which is 1 billionth of a meter. Unbelievably small, right? That is why we can't see these particles separately. Such mixtures are called solutions. In heterogeneous mixtures, like that of sand and water, the size of solute particles is greater than 100 nanometers. That is 10 raised to negative 7 meters. This is why we can see particles very clearly. Such heterogeneous mixtures are called suspensions. Now, in mixtures like milk, the particle size is between 1 nanometer and 100 nanometers. These particles aren't visible to the naked eye, but they can be seen under a microscope. Such heterogeneous mixtures are called colloids. If you look at a glass containing salt water solution, you can see through it quite easily because solutions are transparent as solute particles disappear. Suspensions on the other hand are opaque and colloids are translucent. Have you noticed that if sand water is left undisturbed, the sand particles slowly settle down over time? But the salt in salt water solution don't settle down. Similarly, even milk particles don't settle down. So we can say that suspensions are unstable mixtures whereas solution and colloids are stable. Let us now try to filter all the mixtures. We observe that salt water and milk pass through the filter without leaving any residue. But sand separates out from the water on the filter paper. So, we may conclude that the components in suspension can be separated by filtration, but those in solutions cannot. Even the components in colloids cannot be separated by simple filter, but they can be separated by ultrafilters which are used in water purifications. Some examples of solutions are salt water and sugar water. Some examples of suspensions are chalk water and sand water, while milk, blood, smoke and jellies are examples of colloids. So the next time you visit a beach, you know exactly why sand is visible in sea water but salt isn't. That's all for now. See you next time.